One of the questions on your doubt list is BeCl2 hybridization, beryllium chloride's hybridization. So what is hybridization? Hybridization is when the atom itself directly, there is no logical explanation to why that molecule is forming. When we take the example, it is much clearer. So with beryllium chloride, now beryllium, its atomic number is 4, and if you take its distribution, it is 1s2 2s2 electronic configuration. And when we look at pictorial, it is 1s2 2s2, and the levels of 2p are there but empty. Every atom, this is 1s, that level is filled. 2s, level is filled. 2p, level is there, but it is completely empty. There is nothing in 2p. This, according to Rothbard's rule or Hund's rule, this has lesser energy, so it got filled first. Rothbard's rule. Hund's rule says that after half fill, fully fill should occur here, then it will go to the next level. So it's already paired to S. It's obeying all the rules and it is paired. How will it form a bond when it is already paired? The electrons in 2s are paired electrons. So there should be no reason why this should form a bond. Beryllium should not form any bond. But it does form, and it forms BeCl2, beryllium chloride. One of the molecules, it forms some more also. So what happens here is, these two orbitals, they are very close in their energy levels. The energy level of 2s and 2p are close to each other. So there is a rearrangement of these levels. Now if you look at it level wise, it looks somewhat like the energy of 1s is here, 2 are filled, the energy of 2p, 2s, and this is the level of 2p, empty. What happens to beryllium is, these two 1s remain as it is. These two 2s and 2p, they undergo a rearrangement. They form sp hybridized orbitals. Now for example, if the energy of 2s is say 5 and the energy of 2p is 10, then the energy of this 2sp will be in between 5 and 10, somewhere around 7 or 8. It will not be 5 or 10, it will come in between. This is just an example. The energies of 2s, 2p are not 5 and 10, but this energy of this hybridized level is in between these two, and it has 4 empty orbitals. 2s1, 3 from p, and one of the electron of 2s enters here. So they become 4 sp hybridized orbitals having 1 electron each in this hybridized levels. Both are unpaired, so they are free to bond with some other element. Now consider chlorine. Chlorine's number is 70. If it is 17, its configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. So when we take the last two, it is 3s2, 3p5. So the last p is singly occupied. That is, there is only one electron or unpaired electron in the 3p levels. This one electron of one chlorine binds to this beryllium. First electron, unpaired electron, and one more chlorine will bind to the second electron here. So beryllium, whose number is 4, 1s2, 2s2, it is in ordinary state, it is like this. When it's going to form a bond, it forms hybridized bond. Hybridization is when two energy levels of an atom which are close together, they rearrange, form total number of orbitals. How many ever are the total, that many orbitals they form, and the electrons get redistributed. So there is rearranging of the levels and redistribution of the electrons. So this redistribution of electrons, 2 electrons here, one came to the p level. So we have 2 single unpaired electrons here. Each of this electron binds with whatever is able to take valency 1. So chlorine 17, its valency is 1. So it binds to 1 chlorine each. It looks, when we take the orbital structure, orbital shape when we draw, now the shape of s orbital, beryllium. S is like this, it has 2 electrons. P, the last chlorine's P is dumbbell shape. 1 chlorine like this, another chlorine like this. So 1 electron from beryllium, 1 electron from chlorine, 1 electron from beryllium, 1 electron from chlorine. So this is the shape of hybridized beryllium chloride. Since it's a straight line, we call it shape linear, bond angle 180 degrees. It's a straight line, so the angle is 180 degrees. So beryllium chloride hybridization, beryllium's number is 4, its valency is 1s2, 2s2. After it is excited, that is the redistribution, when it takes place, then one of the electron from 2s gets promoted to the empty 2p orbital, and from there rearrangement of the 4 orbitals take place. 4 empty orbitals will be there, and the 2 will be occupied by the electrons from s. Each will go to 1 of the sp orbital. Hence, it can bind with 2 atoms whose valency is 1. One such atom is chlorine. Chlorine having electronic configuration 17, 1s2, 2s2, 2p6, 3s2 and 3p5. It has electronic configuration, its valency is 1. So that one and the beryllium's capacity to take, share 1. Both of them, they form a bond forming this one. Hence beryllium chloride forms like this, BeCl2, linear molecule with 180 degree bond angle.